All right, it's Mr. Perez just doing a quick fast forwarded version of the solutions just in case the PDF doesn't make sense. So there are 4 parts. I'll go over part A first and go from there. So it looks like Kelly's shape at the right, this one right here, has an area of 17 millimeters squared. So that is a 2-dimensional measurement because we're talking about area. But we want to know if she enlarges the shape with a linear scale factor of 5. So we've got a scale factor of 5 here. What will the area of her enlargement be? So we're actually wondering, what will the area of this be right here? So we know that with the scale factor that the sides of the larger shape will be 5 times bigger. But that's not the case for the area. Actually, the area ratio, we find that by squaring the scale factor. Scale factor squared. That means that the area ratio is actually going to be equal to that scale factor of 5 squared. And that is obviously 5 times itself, which means 25. So we actually know that the area will not be 5 times bigger. The area will be 25 times bigger. So when we take that 17 right here, we're actually going to multiply that by 25. So 17 millimeters squared times 25, and I actually didn't even have my calculator ready for this, but it looks like 17 times 25 gives us 425. So our final answer is 425 millimeters squared. So even though the scale factor means the sides are 5 times longer, that actually means that the area is 25 times bigger. So that's our final answer right there. For the next one, it looks like we have another set of similar shapes. What is the linear scale factor? So we're going backwards this time. And actually, we're going to start with that and then find the area of the smaller figure. So the linear scale factor, that first part, we'll solve right here. So we know that the larger distance across the bottom is 40 right here. And then we've got the corresponding 10 right here. So there are 2 different ways that we can answer it. We're going to go with the 10, so small over large, which means 10 over 40 units, which means that the scale factor is 1/4. So that's actually our final answer for the scale factor. And since we know that we have our scale factor, we can actually now find our area for that smaller shape. So the scale factor of 1/4, since the bigger shape is 4 times larger than the smaller shape, that actually means that our area ratio, so we'll come over here for our area ratio. We'll use a different color just so we know what we're working with here. So our area of the smaller figure is going to be found using the area ratio instead of the scale factor. So our area ratio will be equal to the scale factor squared. So same as before. That means that 1/4 squared, 1/16. So even though the shape has sides that are 1/4 smaller, they're 1/4 the size, the smaller shape actually has an area is 1/16 of the size. So that means that when we take this area of 656, we're going to multiply that by 1/16. So it's not 4 times smaller, it's 16 times smaller. In other words, 656 divided by 16. So our area is actually equal to 41 units squared. So this ends up being our area for the smaller figure. And I'll just go ahead and highlight that right there. And so we've got our 2 answers. The first answer in green, the second answer in yellow. Down to the third question, part C. So the rectangle ABCD is divided into 9 smaller congruent rectangles. And we want to know if the shaded rectangle is similar to the larger one. So when we look at it, we can actually figure out the dimensions for this one. The shaded rectangle, it looks like, so we're talking about this one right here. The shaded rectangle is 2 by 2. So that's this one right here. While the larger rectangle, so it's actually a square if you think about it, and the larger one, if we went all the way A, B, C, D, or A, B, D, C, it's actually 3 by 3. So if you think about it, when we compare our two sides, it looks like our scale factor is 2/3 on this left-hand side, and it's 2/3 on this top side as well. So our scale factor, first to answer our question, yes, they are similar. And then our second part is that the scale factor is equal to 2/3. So that answers our first two questions. And then they want to know what is the ratio of the areas. So we actually know that the area of this shape right here is 4 units squared, while the area of the larger one is 9 units squared. So when we take our ratio, our area ratio is actually going to be equal to 4 over 9, which happens to be 2/3 squared. So we know, as usual, our area ratio is equal to the scale factor squared. That happens every time, and you can set up proportions or figure it out in your own way. Last one, while ordering a carpet for his regular office, Trim was told by the salesperson that a 16 by 24 piece of carpet cost $800. And then he realized that his measurements were wrong and they only needed a 8 by 12. So it looks like the salesperson said that's no problem. Since it's half the size, it will be half the cost. So that's something that we talked about in the notes yesterday. Half the size, it'll be 400. So that's, let's see, half of 800. And we want to know if it's fair. So let's just draw two different carpets. Since it's rectangular carpets, it's not too hard to draw these two. We've got a 16 by 24 carpet right here, and it costs $800. So we know that the carpet is $800. 16 by 24, which means that our area is going to be equal to, let's see here, 384. So the area is 384 units squared, or it looks like feet squared. It's a big carpet. And then we've got the smaller version, which is the 8 by 12. And it looks like, again, since we talk about corresponding sides, that is exactly half the length on the sides. And they said this one was going to cost $400. So when we work with this, again, our area now is 96 feet squared. Even though the scale factor is going to be, let's see here, scale factor is going to be, we'll go with 16, that left-hand side, over 8. Our scale factor is 2, so the larger one is twice as big. Our area ratio, that's where it changes. Our area ratio is actually equal to 384. I'm going to follow the same pattern with the large over the small. 384 over 96 is actually equal to 4, which is the same as 2 squared. So again, our scale factor squared gives us the area ratio. So since it's 4 times as big, it should be 4 times as expensive. Or if we're going in the other direction, when we go from 800, we should be dividing by 4, not by 2. So we cross this out, and it should be only $200. Deal is not fair. This salesperson was going to gyp Trin out of $200. So it is not fair, and that is our final answer.